Something tells me I'm not doing this right. My name's Callie, I'm the OKS engineer, and I need to get this part from real life into CAD land so we can start making some other cool parts. A quick reminder, and for anyone new to the channel, the carbon fiber seat giveaway is still active and going on till January 31st Eastern Standard Time. Go visit the first link in the description, make a comment on that video, and you're automatically entered to win. Now back to the video. Today's video is going to be a little bit different than you're used to. I have so many applications where I have parts in this physical world where I need to get them into CAD so I can do things like CFD or design new molds and parts for this helicopter. But until I had a 3D scanner, there was basically no way to do that. Now that I've had some experience with this scanner, I thought it would be extremely useful to try and put together a tutorial so that you guys could see what it actually takes to use one of these things and how to go from the physical world through a point cloud and into CAD to design a part. So I'm going to step you through that entire process. Please let me know how you like this tutorial. It is a little bit different than you're used to, but I'm curious to get some feedback, and so please let me know how you like it. The 3D scanner we're going to be using to get this part into CAD is called the Einstar by Shining 3D. It comes to you in a nice carrying case. Inside you get a power adapter, a cable to connect it to the computer and then to power, obviously your scanner, which is here. Inside the pouch, you get some tracking dots, which is nice. There's a quick start guide as well to give you some basic pointers. And then behind here, we have a calibration plate, which we'll get into a little later. This scanner uses infrared technology for scanning. So there's a couple advantages and disadvantages to that. It isn't quite as accurate as the laser type, though it does work in a full array of light because the infrared isn't as affected by other ambient light. So you can use it indoor and outdoor, which is a big plus. This particular scanner has raving reviews all over the internet for being able to scan larger objects, which is obviously what we're doing here. And it seems to be very user-friendly without needing to use a whole bunch of tracking dots and minimal setup. The software also seems to be the best for this grade of scanner. So that's basically the reasons why I chose it. The disadvantage though is the software is computation heavy. So we're going to be using a MacBook Pro. It has the M1 chip. This is what they're calling the lower end of what you want. I think it has 16 gigs of RAM. You ideally would have like the M1 Pro chip or an M2 with 32 gigs of RAM, but so far this has done okay. I have run into a couple issues which we'll go over, but for the most part we've done just fine. All right, so this is the Shining 3D software. When you pull it up, it shows you a couple things. The first is that the device is connected. If it is not connected, make sure you plug it in and then re-click the button and it should register that the device is there. After that, it's going to check to see if your calibration is there. If the data is not there or if it's expired, I don't know what the actual timeline is, but I think it's like a week or so. If it hasn't been calibrated within that time, it'll give you a exclamation point, in which case you should probably go redo it again. In this case, it is calibrated, but I want to share with you guys that calibration process. So we're going to go into that. What you're going to do is you're going to get your calibration plate out. You're going to orient it on a flat surface with the dots in the same manner that is displayed on the screen. I also found out that if you don't put this on a flat surface, weird things happen. Something tells me I'm not doing this right. So just if something isn't going right, make sure you are on a big flat surface. After that, you pick up your scanner. It's going to step you through a few things. You're going to click the play button on your scanner and point it directly at the part straight up from the calibration plate. It should display a blue dot and a gray dot. You need to make sure that that blue dot is in the gray dot and you get a green check mark From there, the boxes on the right is your height. So you'll move down and up until all of those boxes are checked. It doesn't matter the sequence that you do that. The next step is to do the same thing, but at a 30-degree angle tilted forward. Hit the play button again, get the circles lined up, and then raise and lower until all of those are green. Do the same thing going back and to the right, and then finally to the left. After that, it will tell you it's been calibrated successfully, and you're going to check your white balance. White balance is just looking for one location. It's in the center and then at that height. Once that's done, you are good to go. And that brings us to the actual project. So here we're going to click New Project Group. We're going to name this Aux Tank. Confirm. There was an error for storage, but I know we have plenty. And in here we have a few options. You have portrait, which we're clearly not doing. We're doing an object. This is a medium or large object. It gives you some rough dimensions. Anything smaller than 200 by 200 by 200, they say do something smaller. And then the mode of alignment. So this is pretty important. This particular scanner does a really good job at just recognizing features. There's some things that can affect that, such as really shiny objects, which this kind of is. We're going to go just as is to see how this works, but we may have to make some changes in the future. You can also put markers on here. We do not want to use markers because those are a pain. Once again, that's those other things you can do to make this more scannable. We're not looking for texture. And we don't want to use global markers, which would be something that you would put like on the ground around it or on a turntable or something of that sort. So right now we're just using features. Resolution, we're going to stick to 1 millimeter. You could go smaller, but I don't need that type of resolution for this. And it's just going to mean that the file's bigger and it needs more computing. So we're just going to use 1 millimeter. Texture scan, we're not using the color cameras on this, so no texture scan either. Confirm, it will open up your new project. And then let's talk through some of these. So you have brightness that controls the intensity of the IR lights, which ultimately scans your part. If it's too bright, it'll blow the sensor out and you won't get good data. So lean on the on less brightness than more. Your working distance is next. This is how close or far the scanner is going to like to be away from your object. I'm going to leave that as default. We have plane detection. This tries to detect a plane that's underneath your part. I prefer just to leave it off because we can detect a plane later. Then that is also coupled. We'll jump down to auto cutting plane. That's going to attempt to get rid of any scan data below that plane. Once again, I'd just rather choose in post. I think it's better that way anyways. We are going to turn data quality indicator on. This changes the color of the scan on the screen from red to green if it thinks that the data is good. So we're going to go ahead and use that as an aid. And then once again, you have this adjust point distance. From there, it's onto the part. So real quick about the part. I have heard that scanners in general don't like shiny objects. This is a shiny gel coat. They do sell a spray that you can spray on that's like a chalk spray that eventually sublimates and goes away. You can do that. You can also put baby powder into acetone, shake it up, spray it on, let the acetone dry off, and then it leaves the baby powder surface to dull the surface. You can put tracking dots onto your part to help with tracking, but that's all a whole bunch of effort that I don't want to do, frankly, and we're going to see if we can get this done anyways. If it doesn't work, we'll find out, and then that's when I can start to progress into other solutions. It would be as easy as just sanding the surface down to make a matte finish, and then maybe that'll make it better. So that's the little blurb I have about the part, and without further ado, let's just jump in. So this is the scanner. There's a play button on the scanner to start and stop your scan. There's also a plus and minus. This does two features. One, it changes the intensity of your IR lights, so you can adjust that right on the scanner. And then it also has a series of lights. So we'll get into this now. The first time you click play, it goes into a preview. You can see on the left side of the screen, there is a bar that goes from blue, green, and then to yellow and red. That is your scanning distance. That gets mimicked again on this top light. If you're too close, it goes red. And then as you get further away, it goes green and then eventually into blue. So it's really nice that you can actually just stare at your scanner instead of having to stare at your screen, and that all that data is there. The plus and minus button I mentioned. So this is the intensity of the light. I'm going to blow it out really quick so you can see what that looks like. This screen over here on the left is what I'm looking at. You can see all that red blowing out the sensor, and then you can see in the middle how it just can't scan that surface because it's just so blown out. So you can then take that back, and you'll see the further I dial this down, actually the better the scan gets to a point, and then it gets a little, I don't know, frayed at the edges. So there is a happy balance. They say you want just a little bit of red on the screen, and I'm gonna go with that. That seems good. All that's left to do is to hit play again, and we'll start scanning. And so that's what we'll do now. So I'll go ahead and hit play. This is going to start to generate a scan. You can see it going from red to green the more it gets confident in that scan. You want to go slow, but you don't have to go too slow. The scanner does not like flat objects, and so as long as that gray scanning area is at least recognizing some edges, everything should be okay. When I was scanning the helicopter, it's such a big, flat, softly curved object. The scanning or the tracking was just a disaster. It just could not keep up. So we're going to get the bulk of this part here, and then I'm going to show you how I plan to get some of the other sides, which is pretty trick and super nice. So I'm just going back one more time. I wanted to make sure I get this corner back here, and we're going to come back and fill that in here in a little bit. So that's probably good enough. So I'm going to hit pause. This is the scan we have so far. Pretty good, pretty happy with it, but there's a location. Let's see if I can get you in there. It was caught by the shadow. See, we're missing all this data. And that's because I never got under there. It was a shadow and it was could never be seen. So what we're going to do is, to make this easy on ourselves, we're actually just going to flip this whole thing over. And then use the software to recognize where the scan left off and start again. So I'm going to hit play, and it's going to preview. It's going to look for the section that it's already scanned, and look at that. It's already picked up where it knows the geometry should be. And this is going to allow us to then scan comfortably the other side. So I'm going to hit play, and then I'm going to rotate around to the top of this part. And we'll hit pause again. And once you've finished scanning your part, there's a few tools you can use to edit the overall scan before it goes into post-processing. The first of which is just a rectangle tool. You use it by clicking Shift and then dragging with your mouse. As you can see, it creates a rectangle. The next is a polygon, so it makes as many lines as you click with your mouse. The third is a lasso tool. Once again, self-explanatory. And the final is a line tool. This actually creates a line and splits the whole part. You also have a paintbrush tool, and once again, you can just draw like you have a paintbrush. It is important to note, though, that if you use any of these tools, it does not stop at the first surface. So you'll see here, I'll put a little shape on this surface that's sticking out, and then you can see now that that selection transfers all the way through to all the surfaces in that part. From there, you have a few more helpful tools to your disposal. We'll go through each one individually, but we'll start with just delete, pretty self-explanatory. The next two you'll use together are called selected domain and invert. Selected domain will select anything that touches the original area that was previously selected. And then invert will then select anything that is outside of that domain. This is especially useful for deleting any of those stray objects or floating things in space. From here on out, we'll be using the polygon tool. I'm just going to run around the entire perimeter of the part and get rid of any of that extra scan data from the table. And finally, we'll use, once again, the selected domain, invert, and then delete to get anything that is no longer touching my part. Clicking the check mark applies the edit, and then we'll wait for it to go into post-processing. And now you can start actually creating your mesh. There's two options here. One, it's just going to create a mesh, assuming that it's a pretty good scan. The second is if you have multiple projects that have been combined together, which apparently is a thing you can do, it will try and sort that out and create a mesh from all those individual projects. I have never been successful in combining projects, and so I don't know, maybe it's me, but I wouldn't suggest you try. I've also gotten this warning every single time I've tried to do a scan. It's basically telling me there's not enough memory to do it and that I should go and rewind the process and make my scan data smaller. Long story short, it's worked every time. The wording here is also confusing. You can either confirm that it's not going to work, or you can continue that it's not going to work. So make sure you click continue. This process could take a little while. It usually gets to 41% and just hangs. So just get up and leave for a little while and let it do what it's got to do. The couple of times that it has not worked for me, it's thrown an error code, but these were all on attempts that I was trying to combine projects. And since I've stopped trying to do that, everything has worked just fine. And the last thing to do here is to mesh your model. And this gives you a few options. You can try to create an airtight or watertight model. You can do things like assigning the max triangle size. You can try to eliminate floating particles. Long story short, from what I've heard, it's best to just use the recommended settings. And for all of the projects that I have done, that's been what's worked the best. So we're going to do that and just stick with the recommended settings. The result ended up being a bit of a surprise for me. You can see that there's some like noisy data and some hard lines and then some clean data. This was weird because the helicopter scan I did, this never happened. The only thing I can come up with is that it was a shiny surface and the infrared lights just couldn't do a good job at measuring them. The easiest way to test this theory was just to go sand the whole surface down. I'd have to do this anyways, so pretty good excuse. All right, so I've sanded all the surfaces back down to like a matte finish, nothing crazy. Let's test this theory out. I have no idea if it's going to work. We're about to find out. And here we have it. The only thing I changed from the last scan to this one was the surface finish. You can see, obviously much better. There are some weird ripples going down the side. I can only assume that that might just be from the resolution that I selected, it being 1mm. This is plenty good for what I'm trying to do. I just needed a rough shape so that I can create a model. So for me, this is fine. And the last thing I want to share with you guys is simplification. This file starts out at almost 2 million polygons and nearly 90 megabytes of an STL file. That's just massive. Shoot for something around the 200,000-ish polygon number. That's going to be plenty sufficient for what you're trying to use, and it'll be much easier to work with in any of the CAD programs that you're using. And that's it. You have a perfectly scanned model. You can save it as an STL, a 3MF, a step, really anything that suits your CAD program most. And once you're done with that, go ahead and import it in, and you can start creating off a model that you scanned from real life. All right, we're back up in the office so I can hopefully share with you guys how to get that scan data into the computer and convert it into something that you can actually use. But before we get into all that, I really need to explain what you can use this stuff for and what you can't. So we'll start with what you can. If you're trying to use this scan data and make, for example, a 3D printed model, that slicing software probably accepts STLs. And you can import that model and basically print what you scanned. Now, there's a caveat to that. It does need to be watertight, so you need to be a little bit more careful and do some more post-processing to make sure that that whole model is watertight. But that is basically something that you can do, scan to 3D print, and you're fine. I guess you could technically do something similar for like making a mold. You could take a 3 or an STL file and boolean out a section from a block, and then you have a mold, and you could go that route. So if you're not planning to alter the scan data, you can get by with it. So what can't you do? Basically what I want to do with it. You can't really manipulate an STL file. It's a point cloud. It's got a whole bunch of polygons. You can't match the contours of surfaces. It's just trash on the modeling side. And so the only way to use your scan is to basically put it into CAD and use it as a template to start designing your own new CAD around it. And that's what I'm going to kind of show you briefly what I'm going to do today. I'm going to import it into CAD, and then we're going to use it basically just to give me sketches to create my own model so that I can eventually grow parts off of that model in its native software, CAD, and it will play nice well together. So you can see now that I've imported the STL file into, I'm using Onshape, but into a CAD software. When it comes in, once again, it's all those little polygons, and so it leaves all the lines, and that's usually visible in CAD software. I like to remove those lines so it's just shaded without the lines, and it gives more of a uniform color, and it's just easier to look at. The next thing you need to do once you have the model in is you need to manipulate it back over to a coordinate system that makes sense to CAD. And so that's what you're going to see me doing here. I'm just applying some planes and sketching in some lines that make sense to the part, and basically creating a coordinate system for the part that I can then translate over to the coordinate system of the CAD software. And so it may look a little messy and does look a little weird, but basically I just need two perpendicular lines that I can call two primary axes, and then that will define the coordinate system that I'll then use from there on out. So once I've got the coordinate system landed there, I then once again translate it over to the CAD coordinate system, and then boom, I've got the part spatially oriented in a way that makes sense and that I can later use in an assembly and easily mate those parts together. With the coordinate system now defined, and now that it makes sense, it's super easy just to create planes and sketches to create your part. I'm not going to go into all that. There's plenty better tutorials out there on YouTube, so please just go do a search for that if you're interested. But basically, I just duplicated the part using the scan data as a template, and this is what the end result is. It's not perfect. I don't need it to be. I just need it to be close. I need to be able to create some parts off of this, and so that'll all get hand feathered in the same way that I did the cowling. So it just needs to be close. The plan is in the future, I need two landing lights on the front of this helicopter, and it only made sense to me to put these landing lights in a little cowling or box right ahead of the auxiliary tank, which is what I scanned. And so I'll be designing that, eventually making another plug, mold, and a carbon fiber part. So I hope you stick around and check those out for another project in the future. And with that, I want to leave you guys kind of with some final thoughts and who I think 3D scanners are for and who they're not for. Overall, the entire process was okay. It was a little clunky though. It definitely wasn't super straightforward and needed a whole lot of basically figuring it out to get it to work. I equate it kind of to like the 3D printers of the world, where, yeah, you can print something, but keeping that printer going and having good success takes effort and knowledge and learning, and you have to want to get it done rather than just clicking print and receiving a part. Same is true for this. If you're willing to work through all the nuances, you can absolutely get a phenomenal scan. I mean, you saw that with the auxiliary tank. I actually got a great scan of the actual helicopter. And so the end result is good. It's just not something that you're going to pick up, scan, and be done. The other part that I mentioned briefly before, it depends on what you're going to use this thing for. If you're just going to scan fun objects and try to get an STL to put into a printer and print something, sure. But if you're trying to reverse engineer something or create something, the whole transition from scanning to CAD is cumbersome, to say the least. In my case, there was no other way. So, and I'm skilled enough in CAD to be able to figure it out, and I'm willing and actually like that challenge. So if you're willing to jump into it and know that it's going to be a struggle, absolutely it's for you. If you're planning to just pick this thing up and hoping you can scan something and have it work first try, I caution you, don't jump into this. It's not just a plug and play type of thing that you're going to enjoy and do on first try. That's going to do it for this one. I feel like I'm a broken record when I say this, but I truly appreciate all the comments and suggestions. As much as I'm trying to share my knowledge with you, you guys have way more knowledge than I will ever have, and so I learn literally just as much as more from you. So please give me a comment, let me know what's going on, suggestions on anything. I truly appreciate it. As always, go build something cool, never stop learning, and we'll see you on the next one.